So, welcome everyone. I hope you can hear me. Sagar, can you just confirm that you can hear me?
Yes, Saurav.
Yeah, yeah. Okay. Thanks. Okay, so welcome everyone. Let me start by introducing myself. I'm an architect currently working with Jacobs on the Neom World project, which is part of the line in Kingdom of Saudi Arabia. I have experience working with automation tools such as Dynamo, Revit API, Python, and C Sharp. Previously, I've built and published two apps on Autodesk App Store, which you can find, which are Formwork tools and 5DV. Apart from that, I have also built projects using tools such as IFC.js, which you can check out. Okay. Okay. So how we will be learning? So whatever we will be doing, we'll be doing on a project-based manner, as in we will be creating complete scripts. We will be covering the theories as we go forward. Okay, so it won't be theories only like, hey, these are lists, these are data types, not like that. We will be doing a particular task with Dynamo, and we will be covering the theories associated with it as we move on, and it will be hands on. So I encourage everyone to start their own sessions of Dynamo in their own computers and follow along as we move. Okay, so what will be learning and what are the prerequisites? So you would require a basic knowledge of Revit to do this, because if you don't get Revit, it's very difficult to understand what we are trying to achieve with Dynamo. Okay, but apart from that, the rest we will be covering from scratch. So if you have any doubts, you can check few of the recordings from last week where we covered the very basics. And also, if you have any questions, feel free to ask. Okay, moving on. Okay, so with that, I would jump on to Revit. So today we will be focusing mainly on geometry. So most of the work that we would be doing today will be focused within the geometry tab of Dynamo, and we won't be going into Revit today. It will be geometry focused. What we will be doing is, as the image that Sagar shared, we will be creating a number of columns like cylindrical blocks whose height change as a ball moves around them, the red color ball, which was shown in the image. So let's start. Okay. This is the geometry tab, and we will start first with, as usual, a point. So this is our first node that we are placing over here. And as you can see, the point has automatically been generated. So as you can see, there it had a checkerboard of a number of points which were going both in the X and in the Y direction. So if we do over here and I start putting in the numbers, I can move the points in either X or Y direction if I want. I can do that also. Sorry, in Y or X, whichever direction we want. So my goal right now is to place a number of points at the intersection of each one of these squares so that I can have a board on which to generate the base of the cylinders that we saw. So in order to do this, it's very difficult to create each and every point manually. Like I can try doing it like Control C and Control V and place every points, like type in. So if I was to do it manually, I would be doing it something like this. Say typing it 1 1. Sorry, I put 1000 over there. Yeah. So I would be placing a point at 1 1, then another maybe at 0 1, and so on, and trying to make the grid, right? But that would be extremely time consuming if I do it like that. So the simpler option is we would feed a list of points into the point by coordinates node to generate an array of points which will create a 2D matrix. Okay. So instead of like copying each one individually and trying to place a point for each one of these coordinates, like similarly, if I want to place the second one, I can do would have manually done it like this. Two, two. Okay. That would have placed a point over here. If I wanted to place the one below, it would have been like this. But this is, as you can understand, extremely time consuming, and we are not going to do that. That really defeats the purpose of automation. So what we are going to do is, instead of doing this, we will still use the point by coordinate nodes, but we would feed it a list of numbers. And in order to generate that list of numbers, we would be using the range option. Okay, so I type in range. So this option comes up. What this does is this generates a list of numbers based upon a few inputs. The first one is a start, like from which number the range should start. So as a starting point, let me put in 0 and where it should end. So for the first time, let's say somewhere around 10. And then there is the option to have steps. Steps as in what interval the numbers will be in. So say something like 1. And now you can see it has run and I have a list of numbers starting from 0 to 10. So if I want to play, say, call this 5, and you can say the list changes. Similarly, if I turn back this to 0 and take this to 2, again the list changes. So this way I can control what are the list of points being generated. Okay. So let's just remove, say, one of these. And let's make this a little larger, 20, say, this to 1. And let's connect it. So as soon as I connect it, I'm inputting 21 points over here, as you can see. You can click on this pin button to expand the list. And let's just bring this up, switch to geometry view. Yeah, so I have a list of points. And as you can see, it has all been placed at the correct interval of 1 mm because it's based on a list of as a step of 1. If I don't want that, I want to change it to 2. You can see I can change the spacing. Okay, so it's up to us, but we will be working with 1 for now. Okay, so now I have a list of points along the x-axis. I would like to generate the same list as we go up along the y-axis as well. Okay, so moving up, I will copy the entire thing over here. And connect it with the y. Okay, not the expected result, right? So now I can see we have a list of points which are diagonal to each other. Okay, like this, because it's taking the combination of the points. If I make this 0, now I have what I desire, but along the y-axis. But what I'm actually trying to create over here is a matrix which has the combination of each of this combination. So if I have, say, 0, 1, 2, 3, 4 over here, so I want need to feed in a list which has as the first digit 0 0, then 0 1, then 1 0, then 0 2, 0 3, 0 4, then again 1 2, 3 2, 4 2, and so on. So in order to achieve all possible combinations like 21 into 21, a 2D matrix of this, what we need to do over here is we need to plug both of this list in and change the lacing of this block. Okay, so what is lacing? Lacing specifies when there are the inputs, how do they combine. So here you can see it's combining the list as is. So 0, the list it is generating is 0 1 1 1 2 2 3 3 4 4. But what we want is we want all possible combinations that are possible from based upon these two inputs. So we will go over here, right click on the block, go to lacings and change it to cross product. Okay, and now you can see from 21 points, all of a sudden we are generating 41 points, and we have our first matrix. See, yeah. So this point will be 0 0. This point will be 0 1. This point will be 1 0. This point will be 1 1, 2 2, and so on and so forth, all over the till over here. Any questions till now? Okay. So now just taking it a little further, if we want further control, like this is a perfect square, maybe we want a rectangle or we want to make it more flexible, so we will be adding a number slider over here. So this is our number slider, and as you can see, if we move, the number changes. So whenever we place a number slider, we must always configure how we want it to change. Here we are dealing with whole numbers, right? So it's 20, 21, 22. We don't want 52.7 numbers like this to come. So we click on this small arrow over here, and this drop down comes up. So this allows us to specify a minimum, a maximum, and a step. So step is at what interval the slider will move. Now you can see, since it's now moving only at an interval of 1, so there are no decimals are avoided. And say I will have a minimum size of 5 and a maximum size of say 40, just so that it does not break my system. So now it is limited. So even if the user is changing my slider, they cannot go beyond this the limits which I have already set. Okay, so now I will plug in this in, and I would be doing similar for this. Let me delete this. Yep. So now you can change the slider as you wish to make the array larger or smaller, like whatever shape you want. Okay. So this is fully parametric at this moment. I will keep the size not too large, as I don't want the system to get bogged down with this. Yep. So now we have our array of points, which was the first task on the list. Okay. Yeah. Let me just arrange this a little bit over here. Yeah. So moving on. Okay. So the first task is there. Now we will move into creating the cylinders. So let me go back to the geometry tab. And here we have a number of options such as curves, abstracts. Okay. We will be starting with curves, which has a number of primitive objects such as arcs, circles, lines available. Okay. For our task, since we are creating a cylinder and the base of a cylinder is always a circle, we will be starting with the circle option. Yeah. Sorry. So this one, center point and radius, have this. And we simply plug the center point over here. And you can see a number of circles have been generated. We will just make a few adjustments so that we can see this more clearly. We will reduce the radius by say 1. 1 is too large, say, or we can increase the spacing over here, the steps. Say the steps we make it 2 so that there is more gap between each circle. Yeah, now it looks better. And say we reduce it to say 0.8. Yeah. So now we have an array of circles created like this. And this again is also fully parametric because each is based upon the input of the node before. So if we were to change this slider, the circle numbers will change automatically with it. Okay. So we are building on top of what already exists. Yep. 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 So we have the circles. So since we have the points and the 2D circles, our first two step is done. We would be now moving on to the solids. Okay. So whenever we want to say take a 2D shape like a circle or a rectangle and turn it into a solid, we need to perform a solid operation such as a sweep or an extrusion or a sweep blend or something, one of those functions. So what we'll be doing is solids. So if we go under geometry solids, you can see it gives us a number of options which we can use to create solids from it. Okay. Like sweep, blends, and so on. Okay. And we are going to use extrusion from here. Let me type in extrusion. So we are gonna take this, extrude as a solid with distance. It has multiple options, of which we are gonna use this one, which is the simplest one. So feeds in with a curve over here. In this case, it will be our circles. And so, as you can see, we have all of these circles created over here. So you can see the circles are also closed over here. There are other extrusion options like this. Instead of say using this node, if we use this, what would have been the difference? Let me disconnect. You can see the same circles are created, but they are not capped. So depending upon what we exactly want to do with the geometry going forward, we have to specify in Dynamo how we want to extrude the base profile, which was a circle or any curve for that matter in this case. Since we would prefer a cylinder with both the ends capped, like closed end, a solid volume, we would be going with the curve dot extrude the solid instead of the curve dot extrude. Okay. So let me connect back. Yeah. Yeah. Any doubt till now what we are doing and how we are approaching it? Okay. So moving on. So what we can do is
Hello,
yeah, hi. Yeah.
hello.
Yeah, I can hear you. Yeah, tell me.
I'm audible. Hello.
Yeah, you're audible. Yeah.
So Saurabh, I was asking the thing which you did regarding the expression and geometry part. I'm clear with it.
Yeah.
Just one question I had is have is that at which stage and where we are going to use this thing, because no one is going to ask us in a company to extrude and do this thing or do this stuff.
Uh, so
And
so
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 where
where
exactly we are going to use this?
so what we are
Any idea
doing,
about it?
yeah, so what we are doing here is we are covering some concepts of the geometry, right? So when you say this particular, what
Hello.
I am showing you, hello, can you hear me?
Hi, yes. You
Yeah.
are audible.
So
Yes.
yeah. So if you want the straight cut answer to this, what I am showing you, this is not a practical application of it. Okay. This is a use case of it, like what you can do with it. Okay. If you say whether there will be a in your fact office you're gonna go and whether you're gonna create so many cylinders together, you're not most likely unless you're doing a playground or something like that. Okay. Or designing a wall such as a what will I say tactile wall or something like that. Okay. But that use case is for you to find out. I am showing you the day your office comes and they say design a tactile wall with say somebody's face on it or somebody like that. How we can do it? Okay, I'm showing you what capabilities the tool has. You understand what I'm trying to convey?
Yes, yes, makes
Yeah,
sense.
yeah,
So basically, this geometry part is something which we cannot model in Revit, but we can after using the Dynamo. I am
yeah,
right?
yeah. So we can, if we did the same thing in Revit, okay, it would have been much more time consuming. And since we are just starting with geometry today, tomorrow what you are saying, I will be showing you a little bit something more practical, which is a parametric walkway. But I will be frank with you, like if you say how much parametric task we do on our office on a day-to-day basis, we don't do much because those projects, even when they come, they're once in a lifetime projects, right? But the concepts apply. You
Yes.
can use the same concepts to, like, what will I say, do a clash detection, check whether an object is within a room or not, right? So I am showing you the concepts of Dynamo today. Okay.
Okay.
Okay. So if you have a use case, the goal is to see this and think, oh, I have a use case, like the one I gave you right now. Like if I'm making a 3D wall or something like that, it's to goal is to see this and say, hey, can I make that? Can I make Charlie Chaplin's face in a wall by just like make it in 3D, like just moving extrusions on it up and down? understood what I'm trying to say, right?
Yes, got it.
Yeah, yeah. Okay. So if you see, there are a lot of examples. Like what I'm doing is not something today new or what is not there already in the internet. You can go and get maybe thousands of example doing similar things. Okay. So the thing is, if you see, there are also examples using images to create extrusions up and down. Okay. But today the goal is to like cover the basics, like how the points come, what is a surface, okay, and what is a solid, in which case we use what. Anyway, yeah. So moving on. So here we have a list of curves available, and we have turned them into the solid, like what we covered till the last stage. Now moving on. So what we are going to do is, since we have each of these elements separated out over here, like split, we can control the height of each of these elements like individually also. So what we'll do is, as a first step, feed in a distance. Okay, and let me change the start. Yeah. You can see the sizes automatically update as I input over here. Now, instead of using this as the range, what we'll do is go back. Okay. So here you can see I have a hierarchical list, right? Like, because it's a matrix, it's a list within a list. So I don't need that. That will increase the complexity as we move forward. What I'm doing over here, I really don't need a list. So what I will do is I will simply flatten it over here at this step. So what I have done over here is I've simply flattened it. So I have a list of solids, just like this. And same over here. Yep. So what we are gonna do right now is we are gonna feed in different distances for each of the cylinders we are creating based upon a different point. So let's create another point. Let's create two number sliders for it. So what we are doing over here is we are simply creating another point. This one. Okay. So let me just move it to 0 for now. Minimum is 0. Let's set the slider. Yep. Let me switch it to manual so that it doesn't always run. So now one of the challenges I have working is I cannot see the points because it is going inside the rest of the geometry that I have already created on screen. So one solution is I can simply select any of this, say like I select the cubes, select any of the node, it becomes highlighted, whatever element is there. I can right click and I can switch off the preview. So the geometry is still being generated, it's just no longer visible in the preview. I can do similarly for, say, not the circles I want to see. I can do it for these points. So you can see all the other points have disappeared. Only the points that I created right now over here, this is visible. This one. Okay. So this is like when we work just to make our lives easier, we can hide individual steps of the process. So okay, so I have a point here whose position I am able to control based upon these two slider. Okay, anywhere I want to place it. So what we are going to do over here is we're going to take this point, which is at say 0, 0, 0 at this point, at 0, 0, 0, and then measure the distance between this point and say this one. 117 points that we have over here. Let me correct for one more thing. This flattening I should have done one step earlier over here. Unless ever we require like hierarchical lists, like nested list within list, we will avoid it. We don't require this flatten anymore. This can connect. Yep. Yep. So this is there. And so we can also get information about the geometries as we work. So one of them is the distance too. If I type in distance too, which literally just gives us the distance between two geometry objects. So anything your points, surfaces, solids are all geometry objects. So here we have the points, you can see. And so what I will do is simply plug this in and plug this in, run it. So I have this array of 177 numbers which specify the distance between the 2 points. Okay. So I can take this and plug this in directly and see what it gives me the result. Let me switch on the preview. Okay. So you can see it disappears the first one and then it creates a array as the distance moves further and further. Okay. If we don't want to do this because say we want the cube to remain, okay, we don't want anything to become zero. So what we will do over here is we will make a minor modification over here so that we have greater control over how these circles are being extruded. What we'll do is now look, we are gonna do what we did last time when we were covering math functions. So we will get the maximum item in the list. Yeah. So we know we have all of these numbers. So we will get the maximum number, which is say 28, and this can vary always, and we will divide it. So- and then run this through this. Okay, we have the case of one being infinity. Okay, okay, so we have all of these numbers which are just multiples of each other, and let me just start. Yep, number. Just replace the infinity with zero. Okay, because we don't need that. So here I'm just trying to clear up the input that I got so that I can have greater control over the numbered list. Not an input. Yeah. And now I'm just gonna multiply it to get a more moderated list of numbers which I can control. Sorry, wrong. So I can type in a full number over here, say 100, and then run this. Let me switch to geometry view. Okay, maybe I don't want it to be so long. Maybe make it 5. So I can scale up and down the numbers as I'm working with it. Sorry, I did one thing wrong. This is what I should have done. Yeah, so I have zeros numbers, and now I multiply, I get only, so I have from 0 to all the way to 5. Yep. So the maximum I can control the list. Yep. So now I can easily control how high I want it to be, because these are all relative to each other, and I won't need this. Sorry, this was not needed. If I connect it directly also, it should work. Yep. Yep. So I have the list, and I can control how relatively so I want it high to be. So if I change 5 to 10, everything will increase proportionally as it goes up. Okay. And what we can do over here is this will change as we move this. So if we move this like this, it will keep on changing as we move this. And you can see here the now the point is, if we move it say somewhere in between, say 14 and somewhere 19, and it will keep on changing. So now I'm outside. So now as you can see over here, like I'm having a little bit difficulty detecting where exactly the point is within the cubes. So what we can do over here is we can create a sphere around that point to make it easier to detect. Okay. So we can simply type in sphere over here. So we have this command. So again, we are doing this just to make our lives easier as we go. Sorry, wrong command. This one. Oh, sphere center point. Yeah. So yeah. So you can see the sphere has generated over here. Let me give this radius, say somewhere around 2, just to make it a little bit bigger. Yep. So now that we have the sphere, while the calculations are still done based upon the points, the sphere will allow us to easily understand where exactly the object is as we move this. I don't, yep. Mm, Let me go back to automatic and go in. So as you can see, as we move it, the sphere, it will automatically change the coordinates of it. Let me go on the other side. Yep. We can increase its height by a little bit just so that the sphere pops up instead of being merged with the rest of it. Say two. Yep. So you can see the sphere over here. So we have the sphere, and as you can see, the cylinders heights will adjust as the spheres move. So what Dynamo here mainly allows us to do is create a geometry which deforms and updates itself based upon the relative position of another geometry, and this can be done with many things. This spheres and this is an attractor point example. This is one of the most common ones out there, but you can do it with other things also. Like you can link it to the size, the volume, and things like that. Also, like you need not only do it with the distance, but this is just an example. So one more thing I would like to cover is, like when we have a lot of geometries, like the case we have in this particular situation, we would like to highlight certain geometries to make it easier. The sphere in this case being. So what Dynamo allows us to do is to color objects based upon like however we want, like to apply different colors to the different objects over here. So geometry by color, if I see, so here is the node. Yep. And if we go and type over here color, a lot of options are there, but we will go with the color palette. This one. This is one of the easiest to use. You can also create the colors by specifying the RGB values, but not going into that much because that complexity is not really required. And we have the colors over here. So in this particular case, I would select red, connect it, and you can see this color has automatically changed to red. So this we can switch off the preview. And as we move this, yeah, it's a little bit slow right now because, yeah, let me just switch it to manual. Yep. Yeah. So that's it. Like, this is like simply the basics, like, of how we can work with geometries within the Dynamo system. So that's it for today. We won't be going in more detail than this for today. So if anybody has any doubts or any portion which they would like me to explain again, feel free to ask. Yeah.
Yeah,
Yeah.
not having any doubt in it. To be very honest, I have seen this work before as well. I
Huh.
just have one question that
Yeah.
see, right now you only told that you are
Yeah.
just teaching the basics
Hmm.
and showing us how what work we can do in it, right,
Hmm.
in Dynamo.
Hmm.
So basically, actually, this knowledge we are getting online. What different I want from you guys, because you are such a big thing, that that where this proper whether you have ever encountered this situation where you have applied in a live project this thing.
So what I have done, I will tell you. Okay, you want an example?
Yes,
I will tell you an example of some of the concepts of this, what you can do. Okay, I
right.
have done a facade. Okay, I will just sketch it out, like, since you're asking. So I've done a facade which has openings on it. Say it has panels. Okay, say like panels, and each panel has an opening on it. Okay,
Okay.
okay.
Mm-hmm.
So these are all panels. Okay, so the panel opening changes. Okay, based upon the, like, the angle it is to the sun, like whether this circle will be like this much or it will be this much. Like, it's like a jal. We have jalis, right? So
Yes.
the design of the jali is based upon, like, the each opening. Like, this hexagon profile can be a square. Like, that was just something, that's a facade, like a aesthetic choice. But the parametric part of it was this opening. So the opening is based upon the amount of sunlight, like the angle to it with the sun. Like, say, like an assumption is made, say the sun at 12 o'clock is over here. Okay, and you have a surface like this. So the opening on the surface is based upon that angle. Like, if it's, say, a curve like this. Okay, and this example also you can see. Okay, I did something similar with just controlling the opening. I did not do cylinders. Okay, I did it with a different, like, the vector calculation between the opening and that. Okay, but that's a use case of it. I can tell you another use case of it which is also very similar, which was the inspiration for this, where they have kinetic facades. Okay, like this, which open and close based upon the amount of sunlight falling on them. Okay, you that also example, I think, is available. Okay, like, it's a kinetic facade like this, and it has like panels like this. This I made long time back. I don't have it right now, but so it has facades, like panels, triangular panels like this. Okay, which open and close based upon the time of the day. So it's a kinetic facade. Okay, so to do that animation, we do that. Yeah, tell me. Sorry. Yeah.
One more thing.
Yeah.
This level of work and this kind of work, I assume this work is coming in a big MNC, right?
Yeah, that also it comes really, as I said. Huh. Like those are one of projects. The example that I gave you, okay,
Yes,
those are like one of, like say one building facade you will make like that, right? If you say every G+4 constructor is not gonna design facades, like make parametric facades, right?
right.
Yeah, yeah, you were saying something.
Yes, that is my question. That see why I'm asking you all this.
Hmm.
See, as a normal office person
Hmm.
or a person
Hmm.
who is working in a like a suppose a startup, so
Yeah,
they are not going to have this kind of maybe problems or maybe they need to model the things. So
true.
what do you suggest that the person like that must first go directly with the scripts having the parameter field
No,
Excel?
so I will give you a I will ask you a question. Answer me this. Okay.
Ah, yes,
Say
sure.
90% people, like what I have also done. We all do flow slabs, like rectangular flow slabs from CAD files. Correct.
Right.
Right.
Uh,
So when you are wanting to do that, okay, you would have to use geometry concept as well, right? I can show you the script in action right now if you want. Okay, and I can give you the script also. Like the example that you are asking for, I think, but this in order to explain this, I cannot start from this. This we will cover, like we were planning to cover it next week. Wait, I will show you the where, like you can say where geometry comes to use, right? So let me show you. Okay, so for example, if I want to create something like this, okay, so this is a script. You have the columns, you have the beams, you select it, and you run it. Okay, and it will automatically generate the slabs for you. Okay, if you can see, you can download the script from here also. Okay, so it will automatically generate the slabs for you, each individual slab based upon the CAD file. But to do this, you need a base in Dynamo, right? To start with. So that's what we are
right.
covering today. So if you want the link, you can just go over here and download the zip file. The script is there. Okay. But if I start today from this, it will be like this Dynamo dyn is there. Okay. So you can try it out. But you need the base. Today we are covering the base. We are not covering how to make this script or say something like say this one. Okay. This say you're doing this, this is performs a Boolean operation between the walls and the, this is a linked Revit model, by the way. So in order to do it, we first need to tell what is a Boolean operation, right? If I just show
Right.
this, that doesn't work, right? Like if you, this script is also available, like feel free to go and download. Okay, but this will be covering later, not now. Today we just started with geometry. Last week we were just doing basics of Dynamo. Okay, if, like how to make this script we cannot cover today, because without the basics, like if you are not clear what is a point and what is a solid, like it's a very different thing learning to make a script and using a script. Okay, if you want to use a script, download it and run it, story ends. If you want to learn how to make a script, then we have to start from the basics, right? That's what we are trying to do. Like any suggestions are welcome, like if you, yeah.
To be very honest,
Yeah,
this is not. I have seen a lot of class of, and this is not you are teaching starting with the
no, no, no,
geometry
no,
and
no, no,
then
no, yeah, yeah,
I
sorry,
have
tell me. Yeah,
I have searched for other classes as well, and
yeah,
same things they are doing. First, they are teaching geometry, and then the other things. But
yeah.
with my experience, I can say without geometry as well, we can understand those. Maybe what you are saying, the advanced things.
Hmm, hmm.
So I don't. I just want to know what is the use of why we need to start
So,
with geometry.
so okay. So why we start with geometry is why we start with any concept, right? We covered last week. We were covering parameters and how to get the information from Revit, right?
Right.
So this week we
Hmm.
are covering geometry. Okay. So say this example you don't want. Say tomorrow we are gonna do a walkway. The plan. Okay, and now you may come and say like this walkway we are never gonna actually build at site. Like how many? buildings are building a walkway. But that is not the goal. The goal is to show a concept and then to apply into 10 other problems. The two examples that I showed you were applications of what I am showing you today. But those scripts in itself cannot be used to show, like, within a 1 hour session, this explanation that I'm giving. Right? That we can go once people are okay, they're clear with what are list, what are sub list, what is lacing. When everything is clear, we can go there. You understand what I'm
Okay,
trying to say? There is a difference
makes sense.
between say learning something and using something. So if you want to use the scripts, download it, use it. But and I'm not claiming that I am the first person to do this thing. This is one of the most common geometry examples for Dynamo that is used. This is like a Dynamo cliche
Okay,
almost. Yeah,
okay,
yeah,
okay.
yeah,
One last thing.
yeah,
I know it is not a part of the topic which we have
yeah,
understood today, but
yeah,
still, you can help me. The thing which we are using packages.
yeah.
So for different scripts, we need to install different packages.
Yes, till now we have not covered anything. I have shown you over the last week or today does not use a single package because we have not covered packages. But yes, I understand your question. Certain scripts require packages for sure. Yeah.
Okay. So
So
that is something which is built by a developer.
no, not necessarily. A package is not necessarily built by a developer. You can packages are a combination of scripts. So there are something called zero touch nodes which are built by a developer. Something like I have it over here. Say, do I have beam more? So if you look at the beam of nodes, say any one of them. So this is built in. This is called a zero touch node. Okay, and
Okay.
okay, so this is written in C sharp and then compiled. And something like say Spring. Let me check. Yeah. So this is something from the watch dialog from the Spring. So the only difference is if I right click over here and click edit, I will be able to go inside the node. It may be
Okay.
Python, but everything, but this is not developed outside of Dynamo. So this is written in Dynamo and packaged as a script. Okay. Just 1 second.
So
This is
is it correct me if I'm wrong.
yeah.
So package is something if we are making something using Python script, then we will call it a packages.
No, 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 no. A package is a collection of scripts together. It doesn't matter what you are using. So if
Even the
I
script, if I'm importing in other scripts, then it is a package.
yeah, yeah, if I am like having a number of scripts together, okay, to make a particular thing, like like if I say I can make a script custom package right now. Say if I say do a number, say number, and I do say 4 plus 4, like very simple. A package doesn't necessarily has to be something complex. And say add, I add this to number and then say I again multiply this. This two tasks I am doing with currently 4 packages, right? Like 2 packages. I'm adding it and multiplying it again, right? So it gives me a output of 32. Instead of doing that, if I say that no, I want to turn this into a package, so I can click on this and click on create custom node and say test. I will delete this later. Test, add to category. Let me just add it to ampersand for this one. So I just have to give it a name, and you can see it's now a single block of things. So
So
packages are group, okay, and this gives the only the output as the 32 because I put everything inside it over here. Okay.
okay, and where to give input in this package?
No, so that depends. So if I instead of doing it like this, if I do over here and create custom node test two, and I keep the inputs out of it, then it will ask for those inputs. It will automatically generate. So creating a package is not a challenge. So you can see test 2 has been created and it takes two inputs x and y and gives the answer 32, which is it adds them and multiplies them. If I give 5, so 5 plus 4 is 9 into 5 again, it's 45. Okay. So packages are just a collection of functions grouped together. Okay. Now there are a variety of packages. If you don't want the internal whatever is known within the package, the logic that is working within the package to be known to others, you create a zero touch node, like what BIMMorph have done. If you're comfortable sharing it with everyone, like what Clockwork and the rest of them have done, then you create a node like this, which other people can go and edit to see what is inside.
Okay, I'm really sorry. But
Yeah,
one last thing.
yeah,
For the packages to run in our Dynamo, we
yeah.
usually save some of the things in a particular path. What is it?
No, no, no,
If you
no.
can.
So any packages you can download from the package manager by searching for a package and all that. Okay. If you're saying you're
Okay.
doing a particular path, then your company is doing a like company wide release of Dynamo. That's why they are adding packages from over here from preference. So what you are asking is how to do a company wide release of Dynamo with say the same packages for everyone. Okay, so that is done. Like I am guessing. I don't know what organization or what type of deployment you are doing, but that is one way to deploy Dynamo. If you want your entire company to be using the same set of packages, then you would add it to a path to a network location over here, instead of each and everyone going and downloading their own packages, like searching and from the package manager. But if you are using it individually, you don't need to like bother about that. Like but if you say a path, I'm assuming you're like running some bat files and adding a path over here to the Dynamo settings. Like that's the assumptions. Like I don't know, again, without seeing your what exactly is happening, I cannot
Sir, I had a
yeah.
question.
Yeah, sure, please go
Sir,
ahead. Yeah.
can we run three scripts in a single Dynamo script? I can write three scripts like 2 plus 2. First 2 plus 2
Mhm.
will run, then
Yeah,
3 plus 3 will run, then 5 plus 5 will run.
yes, we can do it. We can like chain together as many Dynamo scripts together. Like we can do it. That's not a challenge. Like that's easily possible. So the only question that you have to answer over there is, are you modifying anything in Revit between your three scripts? Like if you're deleting a window and taking the wall volume and then taking the wall volume, say you want the volume of a wall without the window. So you're deleting all the windows and then taking the volume of the wall. So for
No,
that,
like not.
yeah,
I'm like, there are three scripts for
yeah,
three particular uses. Okay.
yeah, yeah,
One at once, I have to run one, or for the another complications, I have to run another second one.
yeah.
Means it may vary. When I used to run first script, I will use the first one, and when I used to run the third script, I want the third script. Means uh, otherwise we have to make three dynamic scripts for each functions. Okay.
No, like if you want, if those three functions always run together, okay, then why won't you chain them together? Or are you saying those you want to choose when you want to run function one, when you want to run function two, or when you want to run
Yeah,
function
yeah,
three?
yeah. I want to choose.
Okay, so choosing, it's difficult to do. You I also have not done it, but it should be possible. Like if you want an interface, like a program which says run option one, option two, option three, that you
Yeah.
can do with if then else statements and dispatch. Okay,
Okay.
I have. I also don't remember. I tried it once, but then I don't also remember. But it should be possible. Like you can use this, like if then else. Like you can set a bool parameter over here. Okay, and if it's set to true, something will run. If it's set to false, something else will run. Okay, like if
Okay.
then else statements you can do. It becomes more easier if you're using Python. Then you can just like
Yeah,
say,
yeah. It's
yeah,
easy in Python, but I'm not
huh,
used to in Python, so little bit confused.
yeah. So like, yeah, what you are asking for, I by my knowledge, I think it can be done without using Python also, but it will be the easiest to do with Python because that will give you a easy if then else. Or else, what I will do over here is I will do a bowl mask like this, okay, and I will do a true and false. If it's true, everything will go over here. If it's false, everything will go over on the other side. Like I will do a bowl mask, and so I will use the two other functions over here. Okay, the in and out. The only problem, the out, it will go a null. Okay,
Yeah.
so that will be causing problems. That's why I suggested you use what will I say, Python. Another thing you can do is you can try pass through. There is some a node called pass through in Clockwork that you can try to use. But again, I have to
Yeah,
test it. I have also not done this.
I
Yeah,
tried it, but it's only for two scripts, means not more than two or three.
I understand what.
Uh,
Yeah, I understand what you're saying. You can do with pass through, then if then else. But my question to you will be like the problem you're solving. Huh? Is it
yeah,
worth going into this complexity to solve this issue? You understand what I'm saying? Like
yeah,
what
yes,
you're
sir.
saying can be done. Okay. Like say I would say again Python because then you can use a switch statement. Okay. Because I understand you have multiple cases, right? It's not if then else. It's like
Yeah,
case one do this, case two do this, case three do this, case four
yeah,
do
yes,
this.
sir.
So if that is the situation, my suggestion will be like switch to Python or C sharp or make three scripts and run it with three buttons on the UI. That would be my suggestion.
Okay,
Use
sir.
PyDev.
Thank you.
Yeah. But yeah, it can be done. Not something that cannot be done. Yep. Any more questions?
What is difference between Pyruvate and C sharp? You said we can done it in Python, either Python
Uh,
or C sharp or Pyruvate.
so C sharp is in what Revit API is written in. Okay, you would need
Yes.
a like you would have to do proper coding like within Visual Studio and create a DLL. Okay, to create a
Mm-hmm.
C sharp add-in. Okay, and run it, and then you can even submit that to Autodesk App Store. Like Autodesk will accept a DLL packaged to be a app into their Autodesk App Store. PyRevit or running Revit via Python shell is similar. You have access to almost the same functionality, but here you write the Python script. Okay, PyRevit or Revit Python shell, whichever you are using, will convert it into C sharp and run it. Okay, and you cannot submit a Python script into the Autodesk App Store to be an app. You can use it. Okay, you can deploy it, you can use it, but you cannot submit it to the Autodesk App Store to be used as an app. The connection, if you're doing with C sharp, is much more direct. Okay, but C sharp has a much more, what will I say, steeper learning curve than Python. So it goes into a matter of preference, whichever you prefer. Yeah.
I know that, but better I should ask, instead of asking for difference, better I should ask what is Pyruvate.
Okay, what is PyDevitt? So PyDevitt is this amazing plugin. If you have not seen, okay, let me show you. I will. So if you just Google PyDevitt, okay, just take a look. So this is it's a free plugin, okay, and one of the best plugins out there. Okay, like it itself does a number of like just download it. Like it does a number of functions in itself. Okay, like tools already built in. Okay, and on top of that, you can create your own Python scripts and run it using the PyRevit functions. Because Revit, if you do not have PyRevit or Revit Python shell installed, you cannot run a Python script within Revit. Okay. So, but if you have the installed PyRevit, then you can simply run Python scripts also. Okay. So it's an add-in. It's mainly a Revit add-in. I cannot see where is the PyRevit
Sir, what is
docs.
the difference between Python and Iron Python?
Iron Python is a specific version of Python that is written to work with .NET. Okay, this is again what will I say? Going much more depth into technical. Huh? So the thing is, Revit is based written in C sharp. Okay, so Microsoft has a .NET framework, right?
Yes, sir.
Okay, and again, whatever I say, this is my knowledge. I'm not an expert in this. Like this is like very code deep, not even related to Revit. Like what? So the thing is, if you want to work with .NET programs, okay, from Python, okay, Iron Python is a subset of the Python programming language that works with .NET languages, okay, like the .NET framework. Okay, so if you
Okay,
want to
sir.
use .NET framework with Python, you go with Iron Python. So everything that is available in Python is not always available in Iron Python. Okay.
Okay.
Yep.
So does that mean Iron Python and C Sharp are like of similar?
No, 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 no. They The language is still Python. You will write like how you write C sharp and how you write Python is different. Like how you speak Hindi and how you speak English is different. Iron Python and C sharp is, say, if you're looking at a same book translated in, say, Hindi and in English, that's Iron Python and C sharp. Okay.
Okay, so no relation.
Like the language is different. So the thing is, people are comfortable with different things, right? So if you are comfortable with Python and you want to go into .NET development, Iron Python helps you over there. But if you are already comfortable with C sharp, you would not necessarily learn Iron Python. They're all communicating to the same thing at the end of the day, which is the .NET framework. That is, so .NET framework is the base of Windows on which Revit is made, and we are doing Revit API, which is on top of that. Okay. Again,
So
like, yeah,
maybe I am asking a hypothetical question,
yeah,
but
yeah.
there is saying that Python is the future. So do you think that in future Revit can be written in Python?
This question is for Autodesk.
Right.
I cannot answer that. You are saying whether the entire Revit code base can be rewritten in Python. I don't know, to be frank. Like they're doing Autodesk
Okay.
Forma and all those things. Okay. So I don't know, even if they will rewrite it in Python, they may rewrite it in something like Rust. Okay, because I would say web is the future. Okay. So they may write it in a something like Rust going forward. Like I don't know. Like that answer I
Okay.
don't have. Yeah. Yep. Anything else? Saibal has a question.
No, sir, I already did. Sorry.
Okay, okay. Any more, or else we will call it a day? Yep. Yeah, Sagar, I think we can end it. Yep.
Yes, sure. No issues.
Yeah.
Okay, everybody.
Okay.
Good night.
Good night. Bye.
Good night,
Thanks,
sir.
Saurav.
Thank
Thanks,
you.
Saurav.
Bye. Bye.
Thank you.